Hello everyone, I'm Joe Malovich, and I have a follow-up video here for another YouTube channel that has been working on a hydro system for his off-grid, I guess it's like a cabin, Airbnb type place, and he's having a lot of issues with it. And now I'm not an expert, okay? I just have some experience and a lot of knowledge about thinking about this sort of thing, and I do have an engineering background, so that does have a play in my views here, or in my advice. This is the waterwheel that I built like 3 or 4 years ago for an old place, and there was a lot more flow there. Here there's a lot more head height. Head height is the height of your water source. So I have actually here a hydroelectric system that's running, and it has 117 psi of pressure. It goes up the hill. It's 270 feet approximately in height. Now Loftis, he has only like 6 or 7 feet, I forget the exact value, around his dam. So that is a lot less than I have. So it requires a different situation, a different setup. A setup such as a water wheel. Now I currently have mine bypassed, like my bypass tube here. Yeah, real fancy, I know. Because there's not enough water to actually spin it a lot. Plus it's freezing and the wheel's actually frozen up solid right now. So I can't spin it anyways. So this is letting it kind of like, if not thaw out, then sublimate the ice away so that when it does warm up a little bit, it will spin, and then I can mess around with this gearing system. Now, some of the problems he's having, a lot of them I feel are due to the design of the water wheel. I'll take this pipe off, maybe it can demonstrate some things. It doesn't really look like it. A significant mechanical problem that he has is his buckets come out perpendicular from the wheel, and the problem with that is, so the water falls down into the bucket. So now it's sitting about here on height. And then as soon as the wheel rotates around halfway, then the water can drain out here. So this is his effective height. And you lose a lot of power because you're not using the entire height of the water you have available. Now, a way to fix that is to use scooped buckets like I have here. And that way, when the water gets down towards the bottom, it's still actually, you know, down here, it's still captured in the bucket mostly. If it's a lot of flow, then a lot of the water will have spilled out because it's tilted over so much. But that is a specific problem with mine because these buckets, they return perpendicular. Normally a water wheel bucket will actually be more gentle all the way to the wheel, and it'll be more closer to tangent than perpendicular. Well, that's getting cold because it's filling up. So that's one problem. Another problem is his buckets are really deep. So like mine only go down to here. But his buckets, I'm scaling it appropriately, go down to like here. So your water fills up the bucket down to here, and then it dumps out here. So that's even less power that you have. So you're losing that amount of power there. I know it doesn't seem much, but percentages add up. So to resolve that, you just make your buckets shallower, so they're a smaller portion of the diameter. But in reducing that, then you reduce your total power capacity because you're reducing the volume of the buckets. To combat that, you make the wheel wider. Now, he said in his video he can't really make his wheel wider because it's fixed design within inside those concrete pilings. But he could, and this is another thing, I don't know if he owns the property below it, which is a factor. He could extend his mill race. That's what this pipe is called, a mill race, or sometimes it could be called a flume. He could extend that out past his existing foundation and make the foundation wider. So those are a bunch of things you can do with a wheel. Now, I've been doing a lot of reading about how to design a wheel, because a big unknown is the RPM that you're going to get out of it. And upon my research, and I never really thought too hard about this, it actually depends a lot on the mill race. So we'll say that the mill race should come out, now mine can slide a little bit, it should come out right at the very top. But also, this should be almost darn near touching this. Okay, let me tilt this up a little bit so you're not looking at the top of the screen so much. And water wheels, to a certain extent, have a design flow rate. They kind of do and they kind of don't, okay? So hear me out. The design flow rate determines the velocity of the water coming out here, okay? And from the research I've done, the tangential velocity of the perimeter of the water wheel should be around 93% of the velocity of the water coming out of the mill race, okay? Now, the velocity of the mill race is determined by the flow rate and the pitch, and a few other things like the roughness of the pipe and the amount of fetch, if that's the right term, to get up to a steady state velocity, or a fully developed flow, I believe is the term. And also the profile of the water, the trajectory of the water coming out is gonna be approximately the shape of your bucket, all right? At lower flow rates, the velocity of the water will be less than the velocity of the buckets, but to a certain extent, that's okay, as long as the water wheel isn't spinning so fast that it's actually deflecting the water off of the buckets. But also, so the water wheel velocity, or RPM, will remain the same, but the motor will take less torque off of it. So you get less amps out of it. And so the charge controller will be exposing the generator to the batteries. So the batteries are a load, and the charge controller will expose it less. So the water wheel will spin approximately the same speed, but you get less torque out of it. Another function that may be affecting the actual output is the drive mechanism, whether it be belt or chain. And at least in my situation, I think the chain is not the best option, because in a very wet environment, it's gonna rust, and you're actually gonna wear through the chain very fast, especially with the high torques involved at the water wheel. So high torque and water and low RPM is not good for chain. Now, it might have something to do with the ratio, but I don't really think that's the problem. To a certain extent, within the parameters of the design flow rate or design RPM of the water wheel. At the design flow rate, it provides sufficient RPMs to the generator to charge the batteries. Okay, there's a lot more behind that, but that's what I can think of right now that's simple to explain. At less flow rate, the water wheel will spin at the same RPM approximately. The generator will take off less power, okay? If the batteries are nearing full and it's a direct connected electrical system, then the water wheel will spin faster as it gets full, as the batteries cannot accept the charge, up to the point where a voltage disconnect will disconnect the motor and allow it to free spin. On a water wheel, it's okay free spinning. You're not getting too fast of an RPM generally anyways. Sorry, my ducks are kind of loud. If you have a more complicated charge controller like the Midnight Solar Classic that he has, that I have, then it will seek a optimum or maximum power point depending on the settings. There's a hydro function that has a very slow seek function that will very slowly seek for the maximum power point. You can also set it to very specific voltages if you want to get a very specific RPM out of the water wheel, which may be what you want or not. I don't know, it's very complicated. So let's just say as long as his gearing is appropriate to get under like normal flow design conditions to get enough RPMs out of the motor, then it's fine. Okay, it's gonna self-regulate on its own generally. There may be a few percent to be gained by increasing or decreasing the ratio. The comment that Chris Harbour had about the water wheel rotating at double the voltage that you want unloaded, it doesn't really apply to water wheels. It applies to the other turbine that he has, the other turbine that's actually sitting right there that you guys can't see. It's in the pit right there. And part of the reason for that is that Chris Harbor's turbine and my turbine, very similar turbines, they are impulse turbines. So you have water shooting out of a nozzle and it's getting stopped effectively. Quick note, while I'm editing this video, I realized I didn't complete the thought here. A water wheel will spin at much higher RPMs unloaded. It's just the way they are. I can't really explain it better than that. And they're kind of self-regulating at higher RPMs. If you go too fast, then it's actually going to deflect the water off of the bucket, or just literally fling the water away from the water wheel, so it's self-regulating at the top speed. So half of open circuit for water wheels is generally not a good way to determine the best operating voltage or RPM. It's probably going to be significantly different. It may be a quarter of the open circuit voltage or a tenth of the open circuit voltage. It's really going to vary a lot more than an impulse turbine, like a Alternator turbo. Another function is the size of generator that you have on it. His generator is a 2,000 watt generator. And for that 2,000 watt generator, you have a lot larger bearings. A lot larger bearings mean a lot more friction. So you lose a lot of your potential power to friction. So you always want to have a right-sized generator to the amount of flow that you can expect, or your design flow. I think you mentioned sizing it to around 200 gallons per minute. And so that would be at your 7 feet of drop, I'm just guesstimating here, would be around 250 watts. So that says to me that your generator is like approximately 10 times too large. You're wasting a lot of power in the bearings. So this is my generator. Currently it's set in a constant voltage mode. It's actually 50% of open circuit voltage. So occasionally it will ramp up to open circuit and then clamp down to half of that. So right now it's doing 400 RPMs. And at least in this generator, at 400 RPMs, inside that's 25 volts. Oh, there it's speeding up to check the open circuit voltage. In my case, this generator is probably also oversized. It's a 4,000 watt generator, but I'm only getting, my peak so far is 575 watts. So I'm guilty of oversizing my generator as well. Now, this generator is a three-phase permanent magnet alternator generator, PMG, PMA, whatever. They all have the same function. Dynamo, alternator, blah, it's all the same. This part of the video is actually an edit from a previous upload. I have to go in now and address some things that were factually incorrect. I want you guys to have the correct information, especially Michael Loftis. I want him to know. Well, he probably already knows because he's been talking with Spencer himself. But I want others to know exactly what he's working with. All right? Let me turn this off so I don't have to talk over it. This is a three-phase permanent magnet alternator with a single coil and a single set of magnets. All right? These are like $150, under $200 on Amazon, 4,000 watts rated, approximately the same volts per RPM as what Michael has. Now, what Michael has is a $500 alternator by Missouri Wind and Solar. And what those are is essentially two of these, or more accurately, two car alternators, but modified with permanent magnets, a different style than this. All right, so Michael has a fancy housing with two sets of the coils, two sets of these coils end to end, with a single rotor inside with permanent magnets. So it behaves as if two of these were attached end to end with a single input shaft. All right. What comes out of that is different from this one. This one has a rectifier built in. You can see the cooling fins right there of the rectifier. What his is just the 3-phase part like this, but 2 of them. So he has 6 wires coming out. 3 are from one set of coils and 3 are from another set of coils. All right, those both go inside through 6 wires, 3 and 3. So that's his 2 buried cables with 3 wires each, 1 wire for each alternator inside his fancy housing. And those go to 2 rectifiers that are set up in series to get double the voltage. So his Midnight Classic might be seeing 40 volts, but the voltage going through the wires is the 3-phase AC required to produce 20 volts DC. So he's actually running these wires at a higher amperage and a lower volts per each wire. And in his case, it may actually be better to run a higher voltage DC with one side being positive and the other side being negative, and have the rectifiers down at the turbine, as opposed to running lower voltage AC up to his house and then rectifying it inside the cabin. At that point though, it might be a wash, because the amount of current that he's running through the wires to begin with isn't very much. So like, even I have extension cord here, and this is what, like 14 gauge extension cord, and I'm running up to 10 amps through this and it's fine. But again, I'm only running 20 feet or 30 feet into my garage that's right over there. And yes, those are not necessarily the safest or the best connection, but they work until I can bury a proper wire sometime. I said I was going to do that this past summer, but I never got around to it. Also, we've gotten some wet weather in the past 24 hours, so I think I have enough power or enough water to turn on the large jet. What I'm ultimately going to do is replace this housing with a stainless steel housing with 4 jets that are computer controlled with sensors and a controller tied into my intake spring box up on top of the hill. But for now, I just manually adjust it or replace the nozzles as required. And so this is my generating system. It's still very crude, it's still not done, and there's a lot of things I want to change. But here's where the wire comes in from the generator outside. And then that is connected to this 3-phase bridge rectifier. And then to simplify it, you could take your 2 DC wires that come out of that and then connect that to the battery with either a Xantrex C40, which is a good thing for a dump load controller, that will dump power or just ignore any power coming in when the batteries get full. So your water wheel will spin faster while the batteries are all just topped off and happy sitting there. And then you can use your Midnight Solar Classic to control the charge from your solar panels that I do recommend you get, because hydro, like you said, doesn't work in the summer. And I've experienced that too. Mine goes down to 1 gallon per minute flow, and I can't do anything with that. So I too want solar. So really, you should have multiple sources of power. You can't just rely on one, because seasonally you can get let down. Okay, so Xantrex C40, or you can use a solenoid disconnect, like was also mentioned. The problem with that is it's not going to treat the batteries very nicely. You're not going to be able to float the voltage as they get full, and it's just not going to treat the batteries how they should be treated by a proper charge controller or a dump load controller. So I have it in the percentage of open circuit voltage mode right now. And so open circuit voltage would be 44 volts. So right now it's setting at 22 volts, and I'm getting 11 to 12 watts out of it, which is 1 amp at, well, 12 volts because my batteries were dead. I have my smallest nozzle on right now to do a meager 11 watts, and that's because I don't have a whole lot of flow right now, surprisingly. We have snow, but it's not melting, and it's not actually snowing very much. So it's kind of just dry. There, it went into open circuit voltage seeking. 48, 49, 50, 51. And I switched it over to this mode earlier today, and it will probably go up and up as the bearings out there warm up. Okay, that's clearly not 50%. I must have it set to something else. Let's go see. Mode. Yep, 42%. That's why. So if we go to 50%, enter. Main menu. Status. Mode. I believe it has to be shut off and on again whenever you change the percentage here. All right, now it's going to full circuit test, and okay, it didn't have enough time. So now the turbine's speeding up, and there's 50, should go down to 25. There we go. That's just the one of the many modes that are on this. So I can go to WinTrack Legacy, which is perturb and observe, which is what PO means, is it'll just constantly dither a little bit until it finds a new spot, sit there, wait, and then do it again after a certain time. What says mini sweep every time interval, which is similar to hydro. So I can put this in hydro mode. Interval 2 minutes, so 2 minutes is when it does a little dither here to find a new voltage. Now, because I don't have a whole lot of water flowing out there, the turbine isn't actually going up to full open circuit voltage. Open circuit voltage, for the way it's set up now at 117 psi, will go up to 155 volts. But because I have less water flowing, there's friction from the bearings and the air, both windage and the cooling fan. So that limits the amount of open circuit voltage I can get, or the power in general. So hydro mode works good for my system when it has plenty of water, but when it doesn't have enough water, I put it into percentage. All right, I was watching your second video. It looks like your Missouri Wind and Solar whole charge contraption, it has 2 of these already installed. 2 of these, because these are only rated for, I believe, 100 amps. So for 200 amps of power output, you need 2 of them in parallel. So you have your 3-phase wires coming in. This is 3-phase AC that your generator is making directly, okay? 3-phase AC. So when you have your multimeter hooked up to that, make sure you actually put it in AC mode and check each one of the legs to make sure 1 to 2, 2 to 3, and 1 to 3, that all of them are approximately the same voltage that are going into each one of your bridge rectifiers, okay? Whoa! Jeez. Okay, I'm editing this video together, and I have I've been reviewing your video too. This one here. I was rewatching this video and taking some notes to make sure that I have enough, or all the comments that I want to make for the rest of it, okay? First, I'm just going to go through my list in order. There's no real order to this. The first bullet point is Missouri Wind and Solar. I'm not going to say anything other than you should probably go do your research on that company. That's all I'm saying, okay? I have something of theirs right there even. Very happy with it. Just do some research. Number 2 is to put in a Pelton or Turgo. Typically you would use, I can't talk. Typically you would use a Turgo for low head applications because you have so much water. And a Turgo can handle a lot more water than a Pelton turbine for the same size, okay? Also, you can run a Pelton or Turgo, depends on the volume of water, at below 20 psi. So don't let that stop you, okay? For example, Spencer himself, this is one of his videos from 2014. He has it's 26 volts here. It's a 24 volt system running on, I think I calculated 14 feet of head. And he's getting 2.5 times 26, 65 watts, okay? So he's getting 65 watts out of this, and you probably have plenty of water to flow that. He said he estimated around 150 gallons per minute, maybe 125 gallons per minute at as low as the pressure as he's getting, okay? The second thing about a Turgo is, I know you have multiple sources of water there. So you have the main spring, a secondary spring, and a creek. Okay, maybe not use the creek because then you have to deal with a lot of dirty water. But what you can do is you take those two sources of water, and grab some props here. So you put one penstock at your main spring and a secondary penstock at your other spring. And make sure they're the same height because they probably are on the hillside. And they can flow in parallel down to the turbine, and you get power from both of them. Okay, so they just run together, they supply the same pressure as long as the intake is at the same elevation. Okay, oh, that was a fun sound. Second one, I'll just talk about it here because I want to get this done and uploaded, is I have seen water wheels where, make this where you can see it, so the flume comes out, but the flume actually has guards on the side to prevent the water from splashing off of the water wheel, either to the sides, or imagine you could put a guard on the top to keep the water contained against the top surface of the water wheel. So that's also something to consider for high flow situations. People saying use a car alternator, no, don't do that. They require too many RPMs. Unless they're, I have it right here on my desk, unless they're modified, like this one is a WindBlue permanent magnet alternator, okay? So they took the core out of this and they replaced it with a different permanent magnet core, okay? So this is one option. This has the rectifier built in on the back side. So you have the ground and then your positive terminal here. And this is 3-phase. It already has a rectifier inside it. You could actually take the rectifier out, put it anywhere you want, and then just run the wires from here into other wires and then travel long distances at higher voltages in AC, which is always the better thing to do. People that mentioned a ram pump, that's silly, don't do it. Unless you want like a gravity-fed pressurized water from your spring, then yes, do that. I think that would be great video content. But do not try to pump water with a ram pump to a higher elevation to make power out of it, because it's just pointless and stupid. Don't do it. I think I mentioned earlier, yes to solar. Get the solar panels, you'll be happy. Spencer, again, I don't know if he talked with you about it, but he and I have been working on smaller diameter impellers for smaller diameter low head systems like yours. I made a 4-inch impeller for him. I think I may have even made a smaller one, but really I think it was a 4-inch that he was getting a ton of power out of and not using a whole lot of water. By a whole lot of water, I mean like 400 gallons per minute instead of 4,000 gallons per minute like an 8-inch turbine would require. So you could use one of those smaller siphon turbines like Spencer's building and selling, even in your system with intermittent flow. And by intermittent flow, not really intermittent flow, that's not the proper term, regulated pulsed flow, okay? So what you can do is you could set up if you had a 4-inch turbine, then you could hook up a 4-inch gate valve with a pump switch and a linear actuator that has stops at either end. So they make linear actuators that you could hook up to this ram here, and when the pump switch turns on, then the linear actuator cycles the length and stops. when the pump switch goes off, it cycles back and stops. Now you would need a little bit of power for this, but you'll have power there. You could even have this powering, you could suck a little bit of power off of the generator just to charge a small battery down at the dam, which might be a cool thing to have if you want a little light down there at night, or some other sort of monitoring hardware. Wouldn't be a bad idea. So that's definitely something that you could do. And it would probably be more efficient than a water wheel, because you're using 100% of the head available, at least at your dam. And you could run the tailpipe from this. Typically you want to expand it out from a 4-inch to a 6-inch, so there's less fluid friction. And you could run that 6-inch a lot further down the creek and capture more effective head that way, because it'll be sucking for a larger distance. Another thing you could certainly do is put another water wheel between your spring and the pond. I think that would be cool too. Or if you rebuild the water wheel, I know you don't want to do that, but you could take the old water wheel and put it up near the house as a decoration, powered by that spring water. Okay? So this has been Joe Malovich. There are links in the description for pretty much everything that I've talked about that I could find. Some of them are affiliate links. Buying those, no cost for you, supports my channel, okay? And just as a little teaser for everybody, I know my water wheel out there had a generator motor on it, but I think it was too big. So I've been working on trying to convert one of these to make just a little bit of power, because I don't have a lot of power there available in the first place. And I built my own, so this is a stepper motor. This is a NEMA 17 stepper motor. And I have it hooked up to 2 rectifiers. So AC on one side, DC on the other, but there's 2 phases on this. So there's one phase and another phase, and then some capacitors to even out the power, and just spinning it casually in my hand, I'm making enough voltage to light up those LEDs at a fairly low RPM, which is impressive for any small motor to put out, you know, usable amounts of power at low RPMs. So there's a little teaser for you guys. Now this is going to be set up with a timing belt. I have some GT2. You're not going to focus on that, are you? There we are. GT2 timing belt. And if I put this, what is this? So this is 157 tooth to this, which is, what is it, 16 tooth, I think? You know, I get pretty good power output out of that. Or, I even installed this. I don't even know if I have video for that. It didn't work. I didn't have enough water, it didn't make enough voltage, so it's the same problem that you're having. Where is it? So I designed and printed this. This is a 320 tooth pulley, timing pulley. If I can get it lined up here. The only problem is that it's a lot more finicky for alignment. I might need to reprint this with some larger flanges on the sides to hold the belt in place, or maybe just use a larger belt format. I'm not sure that this GT2 belt would work. Maybe a GT5 5mm pitch belt would work better. You can see the LEDs there are lighting up even at a very slow RPM on this guy. Now it's not a very great representation because LEDs are only like 1.5 volts, but you know, it's something to consider. Like, comment, subscribe, and check out everything in the description, because I probably make money from those links, and that helps me out. It helps me to buy things like this, and like this, and a 3D printer, and my editing computer. You know, 27-inch 1440p monitors are really helpful. I'm very glad I got those. And other cool little things like this RPM meter. Okay, so I'll see you guys around.